Good morning, everyone. This is Mr. Shields back again with part two of our video here. So we're going to pick up with examples 7 and 8. So if I take a look at number 7, we're going to see that once again, we can actually break down both of these terms and simplify them in order to go ahead and actually subtract the numbers on the outside. So let's just go ahead and start here. I'm changing the colors just to kind of mix things up a bit. So if I take a look here at 160, I want to find my biggest perfect square that can go into 160. So looking at my perfect square card, looks like 16. I think that might be the number here. So as a reminder, sometimes you do have to play around with this a little bit, but in the interest of time, obviously I kind of already know what the numbers are just to make sure we keep the ball rolling. But do keep in mind, don't just go for the very first thing you see. Sometimes you might have to go and check even higher in order to make sure that your two numbers under the radical sign are going to end up the same when all said and done. So we said 16 is our biggest perfect square. So 160 divided by 16, that's going to go ahead and give me a 10. And then I can simplify from there. So I'm going to have the square root of 16, which is just 4. I'll bring down that -4 and multiply that. So -4 times 4, that's going to give me a -16. And then, of course, my square root of 10 will come on down. So if I take a look on the left side, I'm going to go ahead and just rewrite this so I make it somewhat symmetrical, I guess. Once I have my square root of 90, I can break that down, and I want to find my biggest perfect square that can go into 90. And that biggest perfect square, consulting my perfect square card, is actually going to be a 9. 90 divided by 9 is just going to be 10. And then I can bring down that -2 here. I take the square root of 9, I'm going to end up with 3 times a -2 on the outside. So I'm going to have a -6 when that's all said and done, with that square root of 10 that I can bring down. So we're in good shape because our two numbers under the radical sign are the same. So that lets me know that I can either add or subtract my terms. And so I have -16 minus 6. So that's going to end up with a -22 square root of 10. Okay, so we're good to go on that. Looking at number 8, I'll slide it over here just a little bit. Once again, we have a little line of demarcation separating the two that we're going to go ahead and simplify. So we'll start here with the 4 square root of 45. And I can break down the square root of 45 by finding my biggest perfect square, which in this case is going to be the number 9. So we'll bring that down here. I'll have the square root of 9 and then bring down my 4. Can't forget about that, otherwise I can really mess things up for you. And 45 divided by 9 is just the square root of 5. And then continue to simplify. Square root of 9 is 3. I'm going to ultimately multiply that by 4. So then I'll have 4 times 3, which gives me a 12. And then that square root of 5 is going to come along for the ride. Now I'm going to have to simplify the other side here. And as you probably already guessed, when I simplify under the radical sign here, I should end up with the square root of 5 under the radical sign. If not, I probably did something wrong. Maybe I chose the wrong perfect square. That's always a potential pitfall that people might fall under. But in this case, I don't think I'm going to make any mistakes on this one. So the biggest perfect square that can go into 245 is just going to be 49. And then 245 divided by 49 is going to give me, you guessed it, a 5. Okay, so we're in good shape. I take the square root of 49 in order to simplify that, and I will end up with a 7. Of course, I got to times it by the 3 that's on the outside. And so 3 times 7 is just 21. And then we'll have the square root of 5 on the inside. And so I'm going to highlight these because since they are the same, that means I can combine like terms on the outside. So 12 plus 21 is just going to give me a 33 square root of 5. Okay. All right, I think I'll do 2 more problems on this back page. I'll give you a second to copy that down if you didn't already do so. Okay, let's look on the back here. And the back is going to be pretty straightforward. What you're going to notice is that instead of 2 radicals, we're actually going to have 3 radicals this time. So a couple of these we can do actually pretty quick. So we might end up doing 3 here on the back side because I think the first 2 are probably going to be really straightforward. So if I have 3 different terms, I want to look for anything that I want to first look for if things are actually reduced as far as they can. In other words, can I simplify what's under the radical sign any further? Well, it doesn't look like I can simplify 10 or 6. Those look pretty good. You know, if I look at my perfect square card, I really don't see anything other than 1 that can divide into all of those. So the good thing is I can highlight the 10s because they're both the same. And I can actually go ahead here about the process of combining these terms. So on the outside, I have a -2 and a -2, which are going to give me a -4. Now that square root of 10 is going to stay the same. That's not going to change. Now, what do you do with this negative square root of 6? Well, there's really not much else that you can do. It can't be simplified any further, so I'm just going to write this down. And you will notice, since the 2 numbers under the radical sign are different, and they're already reduced as far as they can go, this is actually going to be my final answer. If I take a look at number 10, I have a pretty similar setup here. If I look at the numbers under the radical sign, there's really nothing that can be simplified. 1 is the only thing that will go into these. So you'll notice that I have a 7 here and a 7 here under the radical sign. And I'm going to circle these just like what we were doing when we were CLTing, aka combining like terms. I can take my 2 plus my 4 on the outside here. And when I do that, I'm going to end up with a +6 square root of 7. There's nothing really else that I can do with that +5 square root of 3 other than bring that on down. And that is my final answer. All right, so if I take a look at number 11 here, I want to look to see under my radical sign, what can be reduced and what can't be reduced. So 50, I'm pretty certain can get broken down. 18, I'm pretty certain can get broken down. Got 3 under this sign. I think I'm good on that one. I don't think there's much I can do with that. That's probably going to be there at the very end. But the other ones, I think they can actually get reduced a bit. So let's go ahead and play with these in order to eventually add and subtract these terms here. So looking at 50 here, I want to find my biggest perfect square that can go into 50. And you can probably tell that is going to be 25. 50 divided by 25 is just 2. And of course, we can't forget to bring down that -3. That makes all the difference. And so we go ahead and take the square root of our perfect square, which is 5. And then that square root of 2 is going to stay the same. And of course, we're going to have to multiply by that -3 on the outside. When we do that, we're going to have -3 times 5, which is going to give me a -15 square root of 2. And so I've simplified that left term, so I'm good to go there. Now I'm going to have to go on the inside here. I'm going to have to simplify the square root of 18, which isn't all that difficult to do. My biggest perfect square that can go into 18 is going to be 9. So I'm going to have the square root of 9 times the square root of 2. Square root of 9 is just a positive 3. And that square root of 2 is going to be intact. Now, I said on this third term there was really nothing else we could do with it, right? This one gets to go down to the final round without much trouble. And now, after all that simplification, what you should notice is that number 11 now starts to look a lot like problems 9 and 10 here, because we have a 2 here and a 2 here. So that lets me know I can combine my like terms, which is good. So I'll go ahead and circle these, and I'll circle these. So I'm going to have that negative 15 plus 3 on the outside, which is going to give me a negative 12. I'll just have to write my answer over here, square root of 2. And then that minus 3 square root of 3 is going to be right there. And I'm going to go ahead and circle that. We'll put a rectangle around it, or something that looks like a rectangle. Number 12, our last problem here. So, once again, with our perfect square card, I want to find my biggest perfect square that can go into 8, and that number just happens to be 4. And 8 divided by 4 is just 2. And so when we do this, we can go ahead and simplify that square root of 4 here, and which will just give me a 2. A lot of 2's in this one, as you can tell. But we're going to have to multiply the 2's on the outside. 2 times 2 will give me 4. And I'll have 4 square root of 2. So now that left side looks pretty good here. And we just need to go ahead and deal with what's in the middle here. So if I take a look at the 96, I need to try to find out my biggest perfect square that's going to go into 96. My biggest perfect square is going to be 16. And so with that in mind, I'm going to go ahead and write my square root of 16. And so when I do 96 divided by 16, I end up with a 6 here. Now, when I go to simplify here, the square root of 16 is just 4. Of course, there's already another 4 that's on the outside that's going to have to get multiplied. So we'll deal with that. 4 times 4 is going to give me a 16. So I'm going to have 16 square root of 6. And now I have one last thing I can simplify, and that will be that minus 24 here. So when I go ahead and try to find my biggest perfect square that will go into 24, that one's going to be 4. So I can go ahead and take that 4. So 24 divided by 4, and I'm not going to forget my minus sign because that's going to be important. 24 divided by 4 is going to give me 6. Now, when I go ahead and take the square root of 4, I'm going to end up with a 2, but that's going to be a minus 2 because of that sign right there. And then I'll still have the square root of 6. So what's left here? Combining like terms if there are any. So you'll notice that I have a 6 here under the radical sign, and I also have a 6 here under the radical sign, letting me know that I can go ahead and combine these like terms. Okay. So I'll have 16 minus 2 on the outside, which is going to give me a 14 square root of 6. And I can just bring along that 4 square root of 2 for the ride. So I have 4 square root of 2 plus 14 square root of 6. And that'll be my final answer here for number 12. So go ahead and complete the classwork for lesson 3, and I'll see you guys again on the next video. Thanks.